Hello, this is number 1 on the practice exam. We're going to go through it step by step. So we've been given x of t, it's drawn right here. We're asked to find 4 different signal transformations. A asks us to find x of 2t. So x of t, our original signal, looks like this. Imagine that's to scale, of course. This is going to be our transformation space, x of 2t. So the easiest way to do this is to look at the changing points in x of t and find the points in the transformation space that correspond to there. So 3 halves is going to start the graph because x of 2 times 3 halves equals x of 3 in our original space. Okay, so our next point is going to be x of 2 times 1, because that gives you x of 2, which is a changing point, so it's right here, 1. Okay, our next changing point is going to be in the original space 1, so we need to find what value will give us that. So x of 2 times 1 half equals x of 1. So here we are at 1 half. That's the point where we start to slope down, and of course x of 2 times 0 equals x of 0, so it's the 0th point is just the same in both spaces. So that's A, and that's the transformation x of 2t. We can see that it worked to constrict our graph. Okay, B asks us to find x of minus t plus 1. Okay, our original signal x of t looks like this. Okay, so the way to do these transformations where multiple things are happening is you're always going to shift first, because the scaling factor on t is only on the time variable t. It's not on the shift. If you do this in a different order, you're probably going to get it wrong. So just always shift first. So this is x of t plus 1. A shift of plus 1 shifts us leftward. This is minus 1. This is 1 over 1 down, and that's our signal. Not really drawn to scale, but you get the idea. Okay, so now that we have x of t plus 1, we're going to reflect this graph. So this point here is going to reflect over the axis to minus 2, minus 1. This point here reflects over to 1. this point here. I guess you guys can't really see my pen moving. So we get graph looks like this. Okay, that's x of minus t plus 1. So the order of precedence, they call it, is going to be shift. And then scale. In this case, it was by -1, and we call that reflect. Okay, C is given by x of t times ut minus u t minus 2. Okay, so x of t is of course given again as that. Okay, so the first step that we want to do is to find out what this looks like. So this is the unit step, of course. This is u of t. And this is the unit step shifted to the right by 2. This is u of t. This is 1. This is 1. Okay, so we need to subtract u of t minus 2 from u of t. So this is active from only 2 on, and it's equal to 1. This is active from 0 on, and it's equal to 1. So hopefully you see that is just equal to a rectangular pulse between 0 and 2. Okay, so now let's multiply. This is u of t minus u of t minus 2. Now, x of t is right here, as we see. We need to take x of t multiplied by 1 up to t equals 2. So we're just somehow attenuating our signal. This is 1, this is 2, 1, comes up to 1, goes over, and everything else gets cut off. So this is x t times u t minus u t minus 2. Okay. D, final one for this problem, asks us to find x of t times delta t minus 1. Okay, so as always we have x of t Okay, so we mainly just need to decide what what delta t minus 1 looks like. That's just the unit impulse shifted to the right by 1, and it's right here. It has a weight of 1 in this case. So one of the properties of the delta function is that if you multiply it by another function dependent on time, it will select the function's value at the value of delta where it's valid, in this case 1. So this is actually just equal to x of 1. And that point at x of 1, x of t is equal to just 1. So has a weight of 1. And that's what our graph looks like. Okay, number 1's done.